Hello class, today we're going to look at angle relationships in polygons. The textbook reference for this concept is in 7.3. So let's first define what is a polygon. A polygon is a closed figure or shape that is formed by line segments. So in the previous two concepts, we've learned about two types of polygons. A triangle is the simplest of polygon, and then a quadrilateral. So a triangle is a polygon that has 3 sides. A quadrilateral has 4 sides. So today we're going to look at angle relationships in polygons in general. So the one thing we've been consistently looking at is what is the sum of the interior angles in any polygon. In the triangle, we've looked at one and saw that the sum of the interior angles inside a triangle is always 180 degrees. Then we looked at quadrilaterals, and we said that the sum of the interior angles for that polygon is 360. Now I know we looked at proving that the fact that the quadrilateral is 360, but we're going to see if we can prove it in a way that we can use it for all polygons. So one method is if we take the quadrilateral and we split it into triangles. So I form a line segment between one vertex and another vertex in the quadrilateral, and I can see 2 triangles being formed by that line segment that we just drew. Here's one, and here's the other triangle. So if I were to label the interior angles of the 2 triangles, I've got A, B, C, and D, E, F. And we know that each triangle should have a sum of the interior angles to equal to 180. But here we've got 2 triangles, so the sum of all these angles should add up to therefore 2 times 180 degrees, which also gives me 360 degrees. So there we have it. If I can divide any polygon into triangles, I can figure out the sum of the interior angles by multiplying the number of triangles formed by the 180 degrees. So let's use this process for any other polygon. So here I have 2 polygons, and I'm going to find the sum of the interior angles again. In the first polygon, I have 1, 2, 3, 4, 5 sides, and this polygon is called a pentagon. If I use the same process and take one vertex and divide the polygon into triangles, I can make 3. Here I've got 1, 2, 3 triangles. So the sum of the interior angles is therefore 3 times 180 degrees, which gives me 540 degrees. So the sum of the polygon, called the pentagon, which has 5 sides, should have a sum of interior angles to be 540 degrees. The next pentagon here has 1, 2, 3, 4, 5, 6 sides, and is called a hexagon. Using the same process, I'm going to take one vertex and divide this polygon into triangles. And here we have 1, 2, 3, 4 triangles. So the sum of the interior angles is therefore 4 times 180 degrees, which gives me 720 degrees. So this process can be repeated for any polygon that we can create. So in class, you're going to come up with a chart which will help you figure out what the sum of interior angles is for any polygon.